flow labeling. At this stage, that particular knowledge is not necessary for you. And then multicast support also. So the multicast support is clear. Suppose if some of us, 10 of us are viewing one particular movie in this particular forum here. So only once that particular content will be broadcasted to us. So from here, what happens is it will be broadcasted to all of us here on the same time also. So not as a separate stream. So that's what actually happens here. And then these are the other advantages of IPv6 here. So the authentication here, IPv6 really does adapt a lot of authentication protocols, because the reason is with this IPv6, both the content, whatever the content that is transferred across the public network here should also be kept secret, and then the delivery of the content should be to the particular intended person also. So many such are, the security issues are there. So those things are meticulously taken care in this particular IPv6. And then we have the secure neighbor discovery. So with so many addresses, we do not know who is good, who is bad. Yeah, so those things can also be possible here. And then cryptographically generated addresses. So the addresses, when I send an address where the others participating in that particular network they need not know what is the originator, who is the originator of this particular address, because I have intended only to some recipients. So some recipients I will set a key, so the people who are having the key alone can open what is it address and then get with the content. Yeah, and then again with the encryption also. Already I talked about the confidentiality, and then add security layers, and then this already elaborated the simplified header. So because of the simplified header, that is addressing schemes to say what is the destination address, what is the source address here, that the router which is handling the particular packet here will easily deliver the content to the destination. And this is the difference between the IPv4 header and the IPv6 header, where here what happens here, there are a lot of information where IPv6 need to be provided, but those informations are taken out in this IPv6, and then the header content is limited also, as well as number of bytes are also limited. So where in this IP4 it is variable length also. So those things were taken out. Then IPv6 can prioritize the content delivery also. Say for example, suppose some control systems are happening there. Say assume that so many people are here. Now the fire service department, they wanted to know is all the people are right now safe in this particular position or not. So yes, definitely with an IoT it is possible. So if there are any smoke sensors connected with an IoT, if those sensors are sending the information to the nearest fire service department, suppose if senses there is a fire in this particular auditorium, immediately the nearest fire service station should be alerted about this particular problem there. Understand or not? Suppose the sensing, the sensor available here had sent it, and then that information had not reached the fire service station, or say after 1 hour or 2 hours the packet is delivered to the fire service station. So by this time, everything would have been gutted in this particular place. So this is a real time. So real time recon scenario. So within fraction of a second, the information has to reach the fire station, and then the fire station people should deploy. What needs to be done? In the real time mode itself. So such things are possible here. So in this case, what happens in here? Whenever such requirements are there, where we can prioritize that particular packet. When the topmost should be given to this particular packet delivery, so that the network will keep the rest of set aside and then give the topic for this particular information to go first. These are the additional advantages of IPv6. Now, let us have a small, a simple understanding on this Internet of Things. Right now, in this world, the Internet of Things plays a very important role where there are situations everywhere we need to know what are the set data parameters. Say for example, right now I am here in this stage, clear. My body vitals can also be monitored by my body area network devices, which is connected through my mobile devices, and then these mobile devices can seamlessly transfer those information to my physician. Here, the physician can easily check either I'm exceeding some of the vitals or not on the real-time mode itself. So such a requirement. So simply, I'm just taking an example. So what is an IoT as far as my the health monitoring system is concerned? Yeah. So for example, here I have right now a wristwatch. So the wristwatch can measure what is the temperature of my body, but at the same time, the same wristwatch can measure what is my blood pressure, systolic as well as diastolic also. So that is right now available there. And then the can take a pinch of my blood and then find out what is the glucose level in my blood. Either I am exceeding or depleting the glucose level. So like this, I can tell how many number of such parameters. So all these things where I can put an IoT device to monitor these parameters. So simply one example I am telling you here. So these individual devices need to be provided with a unique address. So that's what actually I am coming. This IPv6 is coming into picture. Clear? So these devices has to take these values, and then these values has to be given to this system. So through the system, the data has to go to the server. So the what is it? Finally, value details of my health to be provided to the my physician. Supposed to be any upper limit or lower limit is crossed, then alert should be also provided to the particular physician. So like that, many things are happening there. It has to happen there. So in the same way, there are umpty number of examples here where IoT is playing a very, very important role. So IoT is a small computing device, a tiny computing device with the capability of sensing what is happening. Basically, what is the purpose of this particular sensor? Here, it may be a pressure sensor, it may be say even here also, I can go to another example. So, around 200 seats are there. So now people are waiting outside. Somebody want to know, are vacancy seat available here? So in this particular case, I can put Nokia, a sensing device under the seat. I can find out whether the particular seat is occupied or not. So that Nokia, I can give a provider value to the people who are waiting outside through some of the app or through web services. Anything can happen also. So in this case, each and every device is a IoT device. So if 250 seats are there, 250 such IoT devices. So those IoT devices need to be properly addressed. So obviously it is IPv6 which is coming helping us to provide those addresses also. So like this, okay, I can keep on telling many such applications, real world applications of this IPv6. Then why this IPv6 is very important for IoT. That's what actually the points I am listing. So the huge address space and then the auto configuration also. So the addresses can be easily auto configured, and then header compression. So those facilities are also there. So depends upon the nature of the communication or the environment. Clear? So those things can be compressed also. So those such facilities are there. And then IPv6 dual stack is not an. Well, right now don't worry about those things. So to continue with this IoT, where see the RFID tag is also there. So RFID tag work in tandem with the IP addresses, IPv6 address, and then we have the communication protocol implemented through this IEEE 802.11, that is a wireless protocol. Yeah. So I think you know Wi-Fi. So that is the Wi-Fi is working with this IEEE 802.11, but see that I'm not talking about the Wi-Fi. The router what we have in our house. So that's also the routing device. But I'm talking about a tiny sensor. Yeah, tiny sensor where these facilities are, these capabilities are incorporated. Yeah. So and then see, this is six. Low power. Personal area network. So those standard is also supported with this IPv6. Yeah, Zigbee. So Zigbee network. Configurations can also be integrated with this IPv6 also. And then the sensor and the smartphones can also be. As already stated by the previous speaker, all our telephone numbers are provided only with this IPv6 address. So 128-bit address is there in all our telephones. In the same way, as already told you, whenever we have the sensors, whenever we have IoT devices, so those things will also be given with this the same 128 address. So this is how the IoT architecture functions here. First, we have to find out what is the application on which this IoT device is actually implemented, and then how to connect that particular IoT devices onto the network. Already told you here, IEEE 802.11 or the Zigbee protocols. So those protocols can be easily integrated onto the IPv6 also. See, already I told about the smart cities, smart health, and then smart homes, and then machine to machine. So we are talking about industry 4.4, where it is the machines talk to each other. In this regard, I wanted to quote one simple example. Last week, China has demonstrated a very important capability, the drone. Every day, I used to watch what is the war, how the war is going on between Ukraine and then Russia. In that particular context, day before yesterday, I've seen one demonstration by Chinese military about a swarm of these drones. Have you seen that video? Have you seen that video? Can anybody elaborate on those videos? Have you seen? Anyway, if you have not seen, let me explain. What is the context of this particular video? The video has demonstrated a swarm of drones, small drones, which were here autopiloted. Listen to me carefully. Autopiloted here, and then among the autopiloting, what happens here? It communicates with each other drones. You know, the drones are not flown onto the open airfield. Mind it, the drones were not flown on the open airfield, but rather it is driven on a forest, thick forest. So you understand, here the forest, the drone do not know either the trees there or not, but it has got that adaptability here where the tree is, what is the distance between the trees, and then what happens in the clear? The task is collectively all the drone has to move away from the edge of the forest to the other edge of the forest. See, it is not a simple problem, gentlemen. Clear. Where seamless communication has to happen. Clear. The positioning should also be there. The sensing should also be there. All these things are demonstrated in a tiny, clear, that particular device, the drone. Clear, swarm of drone. So they have demonstrated this really. So now what happens is they are trying to militarize those drones also. Say for example, just I wanted to hit one person over here. So assume that drones are deployed for this particular purpose. So every drone has got a firing gun with it. Now the drone can talk to each other and then exchange information across, so that it can find out which particular drone has got point blank shooting range for neutralizing the particular target also. Can it happen or not? So definitely, this is how the militarization is happening there in this drone technology. But in all these cases, it is only this Internet of Things coupled with IoT, IPv6 nuclear, it is trying to provide nuclear that seamless communication across these devices. So that's what actually, I told, I gave all the detail about nuclear. See the fast communication which is happening, the real-time communication which are happening there. So these are the outcomes, demonstrated outcomes of these particular, the IPv6 capability. Now, see, IPv6, why IPv6 is necessary for IoT? See the rate of information, so within, 100, 200, 300 gigabytes of information are exchanged within few milliseconds itself. Yeah, on the real-time mode. So that's what actually happening here. Anyway, this information, who is providing this IPv6 address already, madam, covered. Again, this is low power body with personal area network. Again, which already, I gave a hint also. Which I don't know to have a deep dive. This is, gentlemen, this is the protocol of Web of Things. Again, for IoT, clear how IoT is playing a very important role in providing even when the information which are systematically in the sense structured information can also be exchanged across also. So structured in the sense nuclear where we can have a table as what we are right now creating a table of the content and then we are sending the table across from one IoT to the other IoT device. So like that it happens. So many such things are happening there. I wanted to skip all this. These are some of the core. Anyway, finally, a few glimpses of what is the difference between IPv4 and IPv6. This already I told 32-bit, it is 128-bit, and then it supports manual and then DX configuration. Here, the dynamic host control protocol. So, now, these the knowledge of these things in nuclear are very, very important to have your identity should be revealed to the other people or not. Clear. So it is the IP address of yours. Who should know? Who should not be shared? So those informations are there in IPv4 as well as V6 also. There are some negative discussions about these particular the privacy as far as IPv6 is concerned. So with the IPsec, so definitely those privacies can also be then implemented as well as to clear in your router itself to clear those such privacies like having an address that is FT80. So that is within 128-bit address. If you give an address of FE80, so that shows that nuclear, your address should not be revealed to others unless you say with whom you want to share those addresses. So, many such facilities are there. So, if you have a deep dive onto this protocol, you will get more information about those things. Clear? And then checksum. So here, the checksum field is available. There, checksum field is not available. So checksum is it is something like nuclear. It is a bookkeeping process here. So say for example, nuclear. Assume that here. Let me teach you what is a checksum and then what is. Suppose we are at the starting of this particular program. The capacity is 200, so 200 are seated and then the gates are locked. Yeah, 200 students are there, faculty members are there. Now gates are locked. Should I check after every 10 minutes those 200 people are here or not? Should I check it or not? Not necessary, because the gates are locked. So once it is there, once you are here, so the same concept is applied here. Here, the checksum. Here. So when you send the information here, so in the next hop, is the same information content is available there, or any distortion or any portion is left over. So those things are not bothered in this IPv6, but rather in IPv4, when you transfer your information from one source to the next, where you have to check whether all the the information which sender has come to you or not. Then again it has to transfer to the next stage. Then there also it has to check. So many such bookkeeping activities has to take place. So in this particular case, it is not necessary because the underlying protocol itself doesn't need such a requirement also because of this IPv6. So then encryption forwarded and then see again this I said IPv6 has fixed header length. Then the last one is an example of an address, how an IPv4 address looks like, and how an IPv6 address looks like. Okay, now I'm coming to the very interesting point, dear students. You are studying in a university where our university motto is what? Our university motto is what, man? Our students are to be job creators, not job seekers. Now what happens in here? You are provided with fundamental technology. Yeah? So now you know what are the technology you are learning, but now it is a stage where you can think about taking some points from these business opportunity and then convert this into business. So that's what actually I'm going to talk about the smart cities. The smart cities are enabled only with IoT devices. These IoT devices are enabled only with IPv6. So this is the chain of what is that connectivity between smart city implemented by IoT. The IoT is supported by IPv6. Here. Now you know the government of India, or even all the governments of all the countries wanted to have that smart city concept introduced. I think you know the reason behind it. So this is the reason behind the smart cities. Yeah. So it is the 0.5% of the total Earth. Yeah. It is only the 0.5% of the total Earth is urbanized. Listen to me carefully. 0.5% of the total Earth is urbanized. Yeah. And then in this 0.5% only of land only, 54% of the entire world lives. 54% of the entire world lives. Then what happens in here? It is the 80% of the economy of the entire world is generated from this 0.5% of the land mass. Understand? Now you understand the connectivity? Clear? So when such huge population is there in this 0.5% of the land mass, now imagine about what is the type of facilities. Clear? What are the requirements of common man? The requirement of common man is I need a good air, I need good water, I need good energy resources, I need good transportation. Good in the sense both cost-wise as well as efficiency. A lot of things are there in this particular aspects. Clear? So this is what actually I said. The structural, so many buildings are there. I want to know, these buildings are stable or not. So what is happening there in Mumbai? Every rainy season, hundreds of people die. We do not know either the building is structurally strong or not. We do not know. But obviously, by having appropriate sensing devices connected onto this various important locations of those buildings look here, we can find out either the structure is safe or not, and then the waste management. Understand? Right now we have totally taken out some of the very nature of Palikana Lake. Have you seen the Palikana marshland? It is totally converted into a yeah. So such a beautiful landmass here, which attracts lakhs and lakhs of birds. But right now, what happens is here, the entire area is not livable also. Unfortunately, my daughter is there living there nearby place. So whenever rain starts, I request my daughter, please come back to my house. It is not a livable place. The type of water and then the type of mosquito menace, all these things look here. It is because of this, the waste management is not properly implemented by this technology. I mean, if you properly use an IoT technology, obviously, just let me give us glimpses of that IoT technology. Where right now, what happens in here? Are you segregating degradable and then the non-degradable waste? Are you doing it or not? No. Government says, please, sort it and then give it separate. And then the other thing is, if it is IoT enabled, so all your bin will have an IoT sensor. Clear? So through this IoT sensor, what happens to clear? Your bin will talk to the nearest depot where that sensor, that particular depot man will know your bin is full or not. Clear? You need not be bothered about, suppose if your bin is full, then immediately you can send the collecting agent to come and collect it. Where you can be there or you cannot be there also. So depends upon the tagging, it cannot be there. So many such things. So and then the noise for air quality also. The ppm. So suppose if ppm is high in the actual road during the peak hours, have you seen it or not? It is non-livable. Here it pollutes a lot of things. So in this particular case, do you have any such an alternate mechanism? So during this peak hour, it is only this electric vehicle which can pass through this arterial road. Do you have any such, data, any regulation imposed on the common man? No. We simply, go across. So these are some of the problems. So if you have appropriate IoT devices collecting all this information is clear. Suppose if that air quality is not livable in this particular location, I can send a broadcast message that if anybody goes through this route, right now the route is closed. If those information is made available to you, so definitely such situations can be eliminated also. Then same thing, the noise monitoring, you can have the same thing. The traffic congestion also. The traffic congestion, I think all of you are aware, the traffic is a real menace. How, it is based on the economy. You suppose if all the vehicles which are supposed to travel 40 kilometers or 60 kilometers within the city limit, if all the traffic goes by 10 kilometers per minute, per hour or 20 kilometers per hour, imagine about the wastage of fuel. Then see the time waste. See, so many lakhs of people are here. Their productivity time is also wasted. So in this, if such a situation is there, if IoT devices are properly installed across the entire city, they can find out where exactly the traffic is generated. Here, where exactly the traffic is moving across. Here, what is the real situation? Either it is a rainy or assume that it is a auspicious day. So many such informations are necessary which has to be fed into the system so that it will give an optimal solution. So if you want to reach that particular place, you go through this particular some other route, not taking this particular route or avoiding certain other vehicles. So many such things can happen also if IoT devices are properly connected in this smart city. And then energy consumption also. Now, just ask your conscience, when you use your washing machine, when are you using your washing machine? Do you have any, predefined practice or not? are using your washing machine for lifting water from your borewell to water tank. Do you have any such schemes? Any such time limits? No. Recklessly we switch on we load the washing machine, we switch on the washing machine, and then again recklessly we switch on the motors, pumping motors, but we are not bothered about the same electricity during night 10 o'clock to morning 7 o'clock. It is used less quantity. Are you accepting it or not? Are you accepting it or not? So where the demand is really less in this time. So during the period, what happens in nuclear? The load, the operating load of the generator cannot be reduced. Again, it has to be put onto the same load itself. So all the generated electricity are wasted. Suppose assume that if you have an IoT devices, that IoT devices talk to each other. What happens in nuclear? Your meter can say that when there is a requirement for more energy, when there is a requirement for less energy. So during the less energy, suppose if your washing machine and then motor pumping machines are connected with an IP address, so then what happens? It is the entire through this single broadcasting nuclear, I can switch on all the washing machine. Provided if you have loaded the washing machine with all the dirty clothes, and then if you keep the washing machine ready, if the washing machine is provided with an IP address as provided by the multicasting of IPv6 with an IoT, so the person who is sitting there in the EB office can send a broadcast message to switch on all the washing machines in one single command itself. Can it happen or not? Suppose if that same thing happens at night 11 o'clock, obviously, where the demand for the electricity is very, very less. Are you accepting it or not? Rather than using during the peak, you can use it in these less hours also. So many such applications can be imagined about with this IoT dear students. And then smart parking also, I gave an example of this particular city. The same thing is applicable to the parking also, the smart parking. And smart lighting also. See how electricity is wasted. And then how sometimes during the daytime itself, sometimes we need light assistance also. Sometimes during the evening hours, we do not need the light assistance. So many such situations are there. So if you properly sense what is the light intensity at that particular point of time, you can change or you can divert the energy to those locations also. So many such applications can be imagined with this IoT. This already told the monitoring of the building. So, dear students, I hope you have understood what is the IoT, and then how this IoT, as an example, I take this smart city. So, how it is enabling new sort of business initiative. Here, many systems. Right now, government buses are coming in. I do not know either there is a seats available there in the bus or not. So sometimes, many of the time it is happening there. So we immediately rush to one bus where we have to stand. But suppose if we wait for 1 or 2 minutes, the next bus will come with all empty seats. Is it happening there or not? Here, suppose if those buses and those seats are connected with IoT devices and then with this IPv6 protocol, definitely through an app I can easily know what is happening there, where the vacancy is there. By waiting for 2 minutes, I can have one more such service provided with the city capacity for which you can ask me to pay for this particular service also. So this is what actually I said. There are umpteen opportunities available for you to become an entrepreneur also. So your imagination is the limit for all this. So technology is there. Think around, find out a best opportunity, try to utilize this opportunity. So for this, I thank the authorities for providing this wonderful opportunity. Thank you.
Thank you, sir, for your engaging and enlightening speech on the topic. Your expertise was greatly appreciated. Thank you so much. Now, I would like to call upon Dr. N. Kanya, HOD IT Department, for the prize distribution session, which was held on 27th May. Now, please, all participants of the debate are requested to come up to the stage and collect your certificates.
Dear students, they are ENS, Dr. Subhasri is on the way. Within 1 or 2 minutes, she will be here. So just give us 2 minutes here. In the meantime, sorry, I forgot to ask, are there any questions from the students community? If there are any questions, I am ready to answer. So you just connect here. No questions. Anyway, if there are no questions, by 2030, listen to me carefully, by 2030, the business through this IoT with IPv6 enabling can come around $19 trillion. So listen to me carefully, $19 trillion. Within another 10, 15 years, these sort of opportunities are awaiting for business through these IoT and then IPv6. Yeah. So the future is for you, dear gentlemen, dear students. Let me place this on.
pleasure to thank you all for the important seminar. On this special occasion, I extend my heartfelt gratitude to speakers. Here it's important to the student to know about IPv6 on this occasion. IPv6 is a vast address space for improved routing efficiency, not a significant leap forward from it than the IPv4. As we continue to see the exponential increase in internet connected devices, IPv6 is not just a upgrade, but also necessary to support the growth and innovation in the various fields. See, what is protocol? Can I have a question? What is protocol? IPv6 is Internet Protocol version 6. What is protocol? All of you are having mobile in your hand, right? Google it and find what is protocol first. Google it. Who is the first person to give the answer?
Let me help you. What is the protocol for your dress code? What is the protocol for your dress code? You have to come in formats. Here, can you come in shorts? Is it allowed? No. Here. So that's also a dress, but it is not allowed. Understand? So this is a set of rules and regulations here which need to be followed during this course of communication is called as protocols. Understand or not? Here. So this is a simple definition of a protocol. Try to, as Madam said, okay, Google it and then find out what are the details associated with on different formats.
Now, the speaker certificate is being presented to Ms. Valikan. Now I call upon the winners of Pradiksha Engineering College, P. Santosh, the winners please do collect your certificates. Kausala Ibrahim, C. Nivedita, Zaga Pavan Kumar, Yanvi Aslam, Harshit Pratap Singh, Vaishali. Thank you, ma'am.
Shall we have a group? So all the winners, please come for a group.
Repeat the certificates, please come to the stage.
At this moment, I would like to express my gratitude to Dr. Subhasri, who is leading the engineering and science campus of our university. So, whenever these sort of statutory day celebrations are necessary, immediately she extends all sort of cooperation for successful running of this particular program. So let us have a big hand to Dr.
Thank you, ma'am. Now I would like to call upon Dr. G.P. Ramesh, Joint Secretary of IEL TVLC, to deliver the vote of thanks. So please.
Good evening, all. Wonderful seminar organized by IPv6 for IPv6. I hope all of you have got knowledge on IPv6 and how it is used, and the application of IPv6 also. So I would like to thank the management of MBR University for giving this opportunity, for providing the space and for providing infrastructure to connect this event. Thank you for the MBR University once again. And I would like to thank the rector, Professor Vishwan sir, for being here for the function and delivering the inaugural address. Thank you, sir. Thank you very much. And I would like to thank Mr. Ganeshan, Dr. Ganeshan sir, to give about the IEA, full details about IEA and how it functions. I hope all of you have sufficient knowledge about IEA to give. Thank you, sir, for giving about the IEA. And then I like to thank all the dignitaries of the dais and auxiliaries for being here for the IEA event and making this event more successful. Thank you one and all.
For the participation certificate, we have circulated the QR code. Kindly fill the QR code. Thank you, sir. I request all members present to stand up for the national anthem.
जनगणमन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल गंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे, तव शुभ आशीष मांगे, गाहे तव जय गाथा। जय गण मंगल दायक जय हे भारत भाग्य विधाता। जय हे जय हे जय हे जय 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 हे।
Thank you to everyone present here for joining us and making this event memorable. We appreciate your presence. Thank you, sir. Thank you, ma'am. Thank you all.